In the last class, we have discussed about biological wastewater treatment. And one of the largest reactor you could see in biological wastewater treatment system. So in the first class, we have mentioned about 5 different categories of bioprocesses. And one of the prominent categories is to produce more biomass. So if your target product is biomass, then you need to develop process to produce more amount of biomass, and using that biomass you can Hello, can you hear me?
Yes, sir. Now we can hear
Yes,
you.
sir.
Okay. So biological wastewater treatment system, they will have different units like the way described about other bioprocess system. So here our main objective is to get more biomass because we know rate of reaction. So rate of reaction in biological system depends on these two factors. One is growth rate, second is concentration of biomass. So in a given system where you have all other environmental conditions are fixed and also the substrate combination is also known or fixed. So you will not get much variation in mu parameter. So for a specific bacteria or specific organism with a given substrate combination and at certain environmental condition, you will get a constant mu value. In biological wastewater system, uh, we use mixed consortia. So instead of having only one bacteria, you will have multiple bacteria. So few bioprocesses are there where you need to use a specific bacteria. That bacteria could be a wild strain or could be a recombinant strain, like genetically modified strain. Whereas in wastewater treatment system, we are not allowed to use any genetically modified strain. The reason is genetically modified strain can be used in a specific location where you have assurance to kill all the genetically modified organism before you discharge anything to the environment. Because the fate of this genetically modified strain is not well known. Fate means whether that will manipulate any other environmental parameter or any other bacteria present in the environment, and that can create some ecological imbalance. So to avoid such incidents, it is a strict regulatory norms to all bioprocess industry wherever they use recombinant strain. Before discharging any waste stream or any biomaterial, they have to ensure that the stream is actually not having any uh, living recombinant cell. And for that reason, for wastewater treatment, it is not allowed to use any recombinant strain. So mostly in wastewater treatment system, we use mixed organism, like you will get tens of thousands of different organisms. And you can have some prominent groups or prominent classes which will do one specific job, but you will not have much control in uh, maintaining sterility in the reactor system. So here for wastewater treatment system, we use weighted average. This mu could be weighted average of multiple organism, or you can have this system having multiple organism and their similar expression. So in biological wastewater treatment system, you can have many organisms, but work-wise, they can have some similarity. So one group can do one specific job, another group can do another specific job, and they may have some interaction also. So essentially, in the reactor system, you are not maintaining any sterility. You just try to grow this organism to get more biomass. And obviously, if you get more biomass, you will get a little bit faster reaction or faster conversion. And whenever you have faster conversion, your requirement of reactor size will also get reduced. And you can treat large volume of wastewater in a smaller reactor. Or reactor will have smaller footprint even to treat large volume of wastewater. Now, typically, biological wastewater treatment system is actually targeting to get more biomass. So essentially, this will come under that bioprocess category where our intention is to get more biomass. And along with this biomass, also you will get conversion of organic carbon, nitrogen, phosphorus, sulfur. Mostly we'll be talking about carbon and nitrogen. Phosphorus is also important, but the concentration of phosphorus sulfur will be much lower compared to carbon nitrogen. Whereas if you treat some specific industrial effluent, then you can have a different other constituents also. So you may have, suppose you are treating fertilizer industrial effluent, then you will have a lot of phosphorus, or sometimes you can have a lot of sulfur, like in um, thermal plant when you try to do coal desulfurization, or maybe when you have petroleum refinery effluent, there you can get a lot of sulfur. So using aerobic or anaerobic process, you can get different end product. If you use aerobic process, then carbon will get oxidized to carbon dioxide, nitrogen will get oxidized to nitrate, phosphate, sulfate, different final product you can get. Now similarly, if you use anaerobic, carbon will give you methane. Mostly this nitrogenous compound in wastewater you will get in the form of ammonia, or relate means it will be attached to different protein molecules. So finally, you'll try to get ammonia, and for removal of nitrogen from ammonia or any other proteinous substance, it will follow oxidation followed by a reduction. So first it will get oxidized to nitrate, and then nitrate will get reduced to nitrogen. Or you can have one step nitrogen removal, that is directly ammonia or any other ammonical substance to nitrogen using anamox. It is called anaerobic oxidation. So anaerobic oxidation can give you nitrogen, phosphorus. Again, you can have B rarely, but you can actually separate this phosphate with the help of some other salt to create precipitation, and then through precipitation, and sulfur can get reduced to H2S, or sometimes even elemental sulfur. Now, based on your requirement, you can choose aerobic or anaerobic. I have earlier mentioned aerobic process are a little bit faster because growth rate of aerobic organism are much faster than the anaerobic organism. So anaerobic reactor size will be much bigger compared to aerobic reactor because reaction rate is faster. So obviously you can treat uh, same volume in a smaller reactor system compared to anaerobic treatment system. So you can get faster reduction or faster conversion in aerobic. Anaerobic system, it will be a little bit slower. Whereas advantage for anaerobic system is you don't need any aeration. So that means you need to just maintain the reactor in anoxic or anaerobic condition. Whereas for aerobic reactor, you need to continuously supply oxygen. So oxygen supply is also an expensive affair. So treatment cost is more in aerobic compared to anaerobic. And anaerobic, another advantage is at the end of treatment, you are getting methane, which has some certain calorific value. So you can recover certain amount of energy. Whereas in aerobic system, recovery of energy is not possible. Rather, you have to use a lot of energy. So this particular process, aerobic process, is energy extensive and or energy intensive process, whereas anaerobic process is not that energy intensive process. So last class I have mentioned this reaction or reactor, or this reactors are the heart of uh, bioprocesses. That means it is your production unit or treatment unit, whatever way you want to tell it. And before reaching that reactor, you will have upstream process and downstream process also, followed by the conversion in the reactor. So biological wastewater treatment system, commonly we get wastewater. I'll just give you description of typical sewage treatment plant. So sewage treatment plant, or commonly known as STP, they are responsible for this. STPs are responsible for treating all sewage. So sewage means the water we get from toilet, and also wherever you don't have any segregation option for gray water, like in the bathroom after taking bath, whatever water we wastewater we generate, in some country they get them through a separate line and they call them as gray water, and from septic tank whatever water we're getting, that is called black water or maybe the sewage. Now in India, most of the sewage treatment plants are getting mixture of gray and black water, means the water from septic tank as also water from the bathroom. So typically per capita water usage in developed country varies between 120 to 200 liter per day. That is per capita water usage. Whereas in India, it varies between 70 to 120 liter per day. So essentially, in a given population, when you need to build a treatment system, biological treatment system for managing sewage, first parameter is your population data. So you need to know what kind of population you are targeting to uh, build this treatment plant. So in Indian context, even if you consider that one person is actually generating 120 liter wastewater, and in a given locality, if you feel that 1,000 people are living, then you can easily calculate what would be the treatment capacity. So for a small town or village having 1,000 population, if you need to develop a treatment system, then 1,000 multiplied by 120, and then also you'll keep some um, safety factor. Suppose you are using 20% safety factor, then you will keep 20% extra capacity, and that will be the final capacity of your treatment plant. So per capita water usage data is very much important to know, or And also the population data is also very much important to know the size of the treatment plant. So you can calculate the volume required in the reactor unit as well as other upstream and downstream operations system to handle this water. So, and Delhi, the population we have means obviously we have a lot of unauthorized colony. So even if you consider census data and then consider the population, then still the amount of wastewater we generate is actually about 1200 millions liter per day. So that is a huge volume. Whereas in Delhi, the current STPs we have, they could handle maximum 50% of wastewater we generate. So that's why you can see in Jamuna River also, which is the major receiving water bodies, that receives almost 50% untreated sewage. And it is quite prominent that if you see the river water quality in Delhi stays, then you will find only sewage in the river. You will not find good water quality in the river. Essentially, that river is actually carrying mostly sewage in Delhi. So if you need to capture the entire sewage, you have to have sufficient treatment capacity to handle the entire sewage. Now, in this sewage treatment plant, first you will have a screen. It is bar screen. So the wastewater will also have a lot of floating materials like floating bottles, plastic bottles, or different polythenes or bigger substances. Now, to get rid of all bigger material or floating material, first you have a bar screen having certain gap. So this screen aperture size will be little bit bigger to arrest all bigger floating particles or bigger floating material like bottles or polythenes or any other bigger substances. So after this bar screen, you will have a fine screen. So whatever finer particles are there, they will get arrested here. And in fine screen, the pore size, so the screen size would be in millimeter, 1 millimeter or less than 1 millimeter size. Now, the particles which are bigger than 1 millimeter, they will get arrested and they will get separated. And all these processes are automatic. Means you have some scraper in front of the screen. So whenever the screen will get blocked, means 80% of the screen will get blocked by the material, a scraper will actually, mechanical scraper will just remove all the debris, and then using a conveyor belt, you will just collect them in a separate chamber. Same thing happens with fine screen also. So it will scrap the surface of the screen and then just put it in a conveyor belt, and then conveyor belt will just take them and through the conveyor belt it will get deposited in a specific chamber, and then you do specific treatment based on their requirement. Like if you get a lot of plastic material, either you can reuse, recycle, or if you get a lot of other combustible material, then you just use them for gaining some energy. So after fine screen, you will have a long channel called grid chamber. Grid chamber is actually a long channel where you have a rough surface at the bottom. So whenever water will flow through this channel, it is flow will get restricted. So whenever you will have restriction in flow, whatever settleable material or heavy material is present in the liquid, they will get settled. So here mostly in the screen you will just remove floating particle. Here you will get other material which are heavier but carried by the liquid. They will get settled here. So mostly soil, then this sand particle, soil particle, and heavier non-degradable substances, or maybe the construction debris, they will get settled here. So from grid chamber, periodically you will just collect the bottom fraction. So whatever material gets settled on the surface, they will get collected in a different line, through a different line, and you can send it to the respective operation. So if you are getting a lot of sand, soil, or construction debris, then you just separate them and dumped in a specific location, because you are not going to get much um, nutrients or any other substances from this settled material. Now after grid chamber, you will have a settler. It's called primary settler. Primary settler. So primary settler is essentially a settling device where the liquid will be introduced through a downcomer, centrally located downcomer, and then the liquid will go up against gravity, because whenever you try to fill this particular system, liquid level will rise, so liquid will go up, and at the outside it has a collection where, so liquid will try to go up, whereas solid material, due to gravity, they will try to settle. So because of the settling velocity, if their settling velocity of the particle is more than the rising velocity of the liquid, then the particle will settle, and through the discharge line you can actually get all settled particle from the settler. So the nutrients, carbon, nitrogen, or phosphorus, sulfur, which are already present in a dissolved form in the liquid, then they will go to, so from the settler, the clear liquid will come from the top, and this clear liquid will be given to the biological treatment system. Biological reactor or biological treatment system. So in the pre-treatment process, you actually have burr screen, fine screen, grid chamber, settler. So these are all part of pre-treatment process. And here from the grid chamber, whatever sludge you will get, the solid material sludge you will get, that will be dried, and if possible to use them in construction, then people will just use them in construction. And similarly for primary settler, whatever sludge you will get, that also, if you get a lot of organic content in the sludge, like if you get heavy fecal matter deposited in the primary settler, then this sludge can be treated in another reactor. Like typically in STPs they use anaerobic reactor to treat the sludge. So this sludge can be treated in anaerobic treatment plant. So from primary settler, you are getting two different stream. One is clear effluent, another is sludge. So sludge can be transferred to a anaerobic digester, AD, and the clear effluent will be, or the effluent will be treated in a biological reactor system. Now we'll give little bit of description of biological treatment system, because you have multiple options. So this upstream is common. Upstream is common, but after upstream, when you talk about biological treatment system, you have option to choose different kind of reactors based on your requirements. So for selecting this biological treatment system, one of the important parameters is characteristics of the wastewater. So you need to know what kind of effluent quality you are getting in the wastewater, and obviously the quantity, because if you get huge volume uh, and if you have space constraint, then you may have to use some advanced treatment option. And this expected quantity and quality, the expected variation means whenever you try to treat them, you may get a little bit of fluctuation in performance, but you need to also comply with the regulatory norms. So different country, they use different kind of regulatory norms to specify the outlet effluent quality. So different pollution control agencies in different country, they have their country specific standards to define the effluent quality. And then finally you need to check available technology, and also you need to do the cost benefit analysis. Now you can see here sewage treatment plants are actually dealing with huge volume of water. Similarly, this distillery, alcohol distillery, they also produce a certain amount of wastewater. So these are the industry where you can get huge volume of wastewater. Paper mill industry, again, they use a lot of water. So there also you can see the amount of water being produced in a given day. But obviously, they'll not be able to compete with the sewage treatment plant. Sewage treatment plant will always have much higher capacity. So whenever you try to use biological treatment system, definitely you need to use huge volume reactor to treat such target volumes. And when you use biological treatment system, essentially you will be dealing with different kind of bacteria. So the bacteria could be aerobic, anaerobic, or anoxic. They will have different kind of metabolic. Um, they will follow different kind of metabolic pathway, and based on this concentration requirement, because in the first uh, and foremost condition we mentioned, you need to get higher concentration of biomass to get faster conversion. So to get this biomass concentration, you will have option to go for suspended cell system. Like in a liquid, you will try to suspend all the biomass, and another option is to just get attached cell system, where you will have certain um, carrier particle or carrier material or support material, where this bacteria will form different biofilm. So attached cell system has some has advantage over suspension system in terms of getting higher biomass concentration in a given volume. So when you try to get the concentration data, suspended cell system will have cell suspension in the liquid, and cell suspension or homogeneity in the suspended cell system will depends on solid holding capacity of the liquid. Like if you just agitate the system to keep them keep the solid particles suspended, then also you need to make sure that settling velocity of the particles should not be higher than the velocity you are maintaining in the reactor to suspend them. Now it has certain capacity, because beyond that, if you keep on adding solid, after a certain period of time the solid will get precipitated. So suspended system has limitation to get a certain amount of solid in a given volume, whereas attached cell system, in the same volume, if you use multiple Suppose you are using multiple plates, and both the sides of plates are actually having biofilm. So in given volume, same volume of reactor you are using, and you can actually get more amount of biomass in given volume if you use this attached cell system. So attached cell system is a little bit beneficial when you try to get more biomass concentration in a given volume. And another major advantage with the attached cell system is the system is more resilient towards toxic compounds, because if in a suspended system, if you just add small amount of toxic compound, it will get distributed evenly because you are maintaining good homogeneity. Whereas the attached cell system, first the toxic compound will come in contact with the outer layer, and then it will try to percolate through by diffusion, and then try to contaminate the inner layer. So this diffusion through porous media of porous film is much slower compared to the convective transport of pollutant in suspended cell system. So obviously suspended cell system can experience the toxic effect of any toxic compound very quickly, whereas that exposure time will be a little bit prolonged in terms of attached cell system. So that's why attached cell systems are a little bit more resilient towards toxicity, whereas suspended system are more vulnerable to toxic compounds present in the environment. Now, different reactor configurations are used based on metabolism and also the suspended and attached cell system configuration. So you have aerobic process, anaerobic process, and in both the system you have suspended and attached cell system. Now, typically in aerobic process, activated sludge process is one of the common treatment system we use. Then you can have sequential batch reactor. So we'll discuss more on ASP. Then you'll give a little bit of description of sequential batch reactor. For attached cell system, the common design is trickling filter and rotating biological contactor. And suspended cell system for anaerobic, you have anaerobic contact process. It is very similar to CSTR, anaerobic CSTR. And for attached cell, you have multiple option. Common option, one of the common reactor is aflow anaerobic sludge blanket. It is a type of moving bed reactor, bioreactor. And then you have this anaerobic filter. It is again similar to trickling filter, but in trickling filter you maintain aerobic condition, whereas anaerobic filter you use anaerobic environment. And then also you have anaerobic fluid as bed reactor. So these are all some commonly used reactor in different industry, bioprocess industries. And so in wastewater treatment plant, as a representative of aerobic system, ASP is commonly used, activated sludge process. And for anaerobic treatment, USB is another reactor which is commonly used for treatment of different kind of wastewater in industries. So for aerobic, we use suspended cell system. That is one of the common design. Whereas for anaerobic, the most common design is attached cell system, and that is aflow anaerobic sludge blanket or UASB. Anybody has any question on this?
So
Okay.
what are the differences between all of these?
All of this means, are you talking about the last
Yes, sir,
section?
the last one.
Achha. So So suspended cell system means you will have a reactor where all the solid particle means that your biomass will be maintained in suspended condition. So all these particles will be suspended, or we'll just try to keep them suspended using different means. Either you can use aeration, like you just supply air to maintain the churning motion. So this liquid, the solid particle will not be able to settle at the bottom. You'll just try to fluidize or keep them suspended in the liquid with the means of aeration. You can have stirrer to maintain the mixing condition in the system, and then you keep them suspended. Or you can have external recycling line. You can have a pump which will just draw the liquid along with the solid and then send them back to the reactor. So you'll have continuous recirculation. So a different method can be used to keep them suspended. So that is one means these are the common methods to use to keep the solid suspended in the liquid. So wherever you use aerobic treatment system, you can use aeration. So you can use air or oxygen. Commonly we use air to keep them suspended. Or you can use surface agitator. So you will have mechanical surface agitator. So this surface agitator is actually similar to this impeller or stirrer. Only thing is they will not have the extended shaft and other impeller mounted on them. They will have only this much portion, and it will agitate the liquid in such a way that it will help the surrounding air to get dissolved in the liquid, and also it will create agitation in the liquid, so it will have circular motion in the liquid. So essentially the surface agitator, mechanical surface agitator, they are used for aeration plus maintaining this recirculation in the liquid. And another option is to use sparger at the bottom, spine sparger that could be made up of membrane material, that could be made up of ceramic membrane, rubber membrane, or you can have the simple nozzle or jet or different membranes. And then you create bubbles, air bubbles. So air bubbles, whenever they will move up, they'll create the churning motion, so it will not allow the solid to settle at the bottom. And recirculation is possible if you have centrifugal pump. So you just put a centrifugal pump outside the reactor, it will just collect the liquid and then put it back to the system. Now, aerobic system, all these options are possible. Like surface agitation is possible only with aerobic system. The sparging through the membrane or jet nozzle is possible if you use aerobic as well as anaerobic. So only difference is anaerobic system you have to use any other gases than oxygen. Like if you use nitrogen or methane, then it will not interact with the biomass. Whereas in aerobic system, you will just use air. And recirculation can be done either in aerobic or anaerobic system because it is completely sealed. So you are not introducing any air or anything in this system. So ASP is typically a CSTR with cell recycle. So in chemical engineering, you must have in CRE, you must have read about CSTR followed by settler. So you have a CSTR, and instead of using stirrer, you just use air sparger to create the movement of the solid, and after getting sufficient amount of biomass, this liquid will be transferred to a settler, and the settled biomass means some portion of settled biomass will be recycled back to the reactor, and a certain amount will be discharged. Now, in all treatment system, one of the common parameter to know how much biomass is required is actually estimated using a ratio called food to microorganism ratio. Food means the waste nutrient are food to the microorganism. So you know concentration of food to microorganism. So food to microorganism ratio is very much important, and you need to know how much F by M ratio is required in this kind of reactor system. So you will just try to maintain that microorganism concentration. So through this recycle line, you add the microorganism to maintain F by M at a constant value. Now, as this organism, whatever you grow in the reactor, they are still active, and you just separate the active organism and put them back to the reactor. So whenever you have this active organism in the reactor, you are just getting them as sludge, because the solid particles, whatever is generating in the reactor system, they are known as sludge. This sludge will get separated in the settler, and again, some portion of this active organism or active sludge will go back to the reactor. That's why this process is known as activated sludge process. So you actually, instead of calling it as CSTR with cell recycle, you call it a activated sludge process. That means you are actually dealing with active sludge. Now, sequential batch reactor is a different configuration where you have multiple batches, multiple batch reactors, and you just run them sequentially. So first you do one kind of operation here, and configuration wise, it may not be very different. Only thing is here you don't have any cycle line. You have same aeration line. Now, in the first reactor, you will do little bit of carbon removal, suppose, and then you get a little bit of removal of nitrogen or conversion of nitrogen to nitrate. Second reactor, you can have a, it means you maintain little bit different conditions to target removal of other nutrients. So in this way, you can have multiple reactor operate in a sequence. So there, in this case, it is a continuous system. Here also, individual reactors are running in a batch mode, but overall process is continuous. So you add certain things here and wait for its batch time. Then you put that content in other reactor, wait for the batch time. So whenever the first batch is processed in the second reactor, that time another batch will actually get processed in the first reactor. So essentially, in a reaction flow, you will actually get constant movement of effluent, whereas internally, different reactors will actually operate in batch mode, and they will operate in a given sequence. So that's why they are known as sequential batch reactors. Similarly, the suspended system anaerobic system is very similar to the CSTR or SBR. Only difference is they will be completely covered, and they will not have any aeration line. Even for mixing through, mixing mostly done by agitation. So you will have stirrer instead of sparger, you will have stirrer, and then you will just do mixing in the anaerobic contact process. And the remaining reactor configuration we can discuss in the next class. So one more important thing I'll mention here. I know today is Saturday, although it is declared as working uh, days because Friday was holiday. But I could see only 8, 9 students in the class. and where the total strength of the class is around 70. So obviously it is not expected. I know many students may have issue with connectivity or your COVID, but all these issues should be flagged well before, because if you are not well, you can just mail me that you are not well. But if you don't attend the class, and then it doesn't look good in different ways. Obviously, the time whatever you have, if you utilize in a better way, then nobody is going to say anything on that. But that doesn't happen. So to give some benefit to the student, those who are attending the class, we'll just organize some surprise quiz, and we'll try to give certain weightage on that surprise quizzes. So it will benefit the student, those who are regularly attending the class. And we have already mentioned 30-30 for minor and major marks, and remaining will be for assignment and other discussion. So within that 60, we'll keep certain component for these surprise quizzes. We'll not ask too many questions, maybe 5 questions or 6 questions in the surprise quiz. So those who will actually attend the classes, they will get benefit. And even for this also, because now Microsoft team is actually giving us complete attendance data with timestamp. So I could actually see how many students actually joined in the beginning and how many students just joined just before the end of the class. So based on that, because it is happens whenever we announce for any surprise quizzes, definitely will intimate your friend and they will also join. But it is definitely with me also to choose whose answer script should be considered for evaluation and who should not be considered. So if I see somebody has just joined the class for attending the exam, I'll not consider that answer script. So those who are present, they will at least get some benefit, and those who are not present, let them not get the benefit. I hope it is a reasonable argument. Is it okay with all of you?
Oh, sure, sir.
Sir, if the students are start attending the classes, so like, uh, will the surprise quiz will still be there?
The surprise quiz will not make much difference to your performance. Reason is, if you attend the classes,
Yeah, yeah.
sometimes it also happens. You just sometimes it also happens. You just log in, and then you keep everything muted, or maybe you can just keep your speaker also on mute, and you sleep. So that will not make any difference. Mere attendance is not going to give, means you are not going to get any benefit through that. So if you attend the class and the kind of question we'll ask in the surprise quiz, they'll be very simple. So you need not to worry about that surprise quizzes. If you attend, you can definitely answer the quizzes. It's like if I just ask you the full form of ASP, definitely you'll be able to answer it. So I'm not going to ask very difficult or tough questions. It is just to give some benefit to the student, those who are attending the classes. Is it okay?
Yes, sir.
Yes, sir. Yes.
Okay. Okay. So, so who is the class representative here? At least uh, for any other future communication, I'll actually know the class representative, so I can send a mail to the representative, and he or she can actually convey the message to the entire class. So who is your
So the
class
class
representative?
rep is Dev Priya. Dev Priya.
Okay, let me check whether we could see the class representative here or not. No. So can maybe one of you can actually request class representative to attend the classes.
Sir, I guess he was having some problems with his health. That is why he couldn't attend.
Acha. Those who are actually having genuine issue, we don't have any problem to actually consider the classes, we consider the cases, and we can conduct separate quizzes for them, but obviously we need to check their their request also. Many students, they use different excuses, and you may not. I don't know whether you have heard it from your seniors. Now, most of the companies, those who are recruiting students, they have created a separate cadre. So they are telling these are all COVID graduates. And unfortunately, they are telling that most of the students, those who have actually got recruited during this period, their fundamentals are really, really very poor. So classroom teaching and online teaching, there is significant difference. One of the major differences is the student participation. And when you attend classes in the classroom, at least something will hear, means even if you try to engage yourself for some other activity, still it will not be possible because you have to listen something, whatever is going on in the class. But this is not very prominent with this online lectures. Anyway, hopefully we'll get more participation in future. So maybe one of you can actually convey this message. So at least the student, those who will attend the classes, they'll get some benefit. And those who couldn't attend, definitely they have to be happy with the other sections like minor, major, and other component of evolution. Okay, okay.
Sure, sir.
See you.
Thank you, sir.
Okay. Thank you. Thank you. See you next week then.
Thank you, sir.
Thank you. Yes.